one animal, alone, at the edge of a tree line as the light goes flat orange, then gray. Not fast, not strong, no claws worth the name, nails instead, built for gripping fruit, not for opening flesh. Canines too small to settle a fight. Skin bare in patches where a heavier coat used to sit, so the cold gets in the second the sun drops. Something moves low in the grass, and this animal has exactly one option that actually helps. Get its back against something solid, and hope another set of eyes nearby is already awake. A lion can close ground at well over 60 kilometers an hour in a short burst. This animal, sprinting flat out, tops out somewhere around 25. Alone, on open ground, after dark. That gap in speed isn't a disadvantage. It's a death sentence. And for a very long stretch of hominin history, it was exactly that. Over and over, until something changed. If this is already landing, subscribe and let us know in the comments where in the world you're watching from. That scene is roughly the starting condition for any hominin that stepped out onto open, thinning woodland several million years ago, and it invites a question people ask constantly and then answer with a shrug. Early humans banded together for safety. True, technically, and also almost useless as an explanation, because it treats group living like a lifestyle choice, something picked off a shelf the way you'd pick a better cave. It wasn't. Solitary living is the default setting for most mammals on Earth. Tigers hunt alone. Bears den alone. Even most primate species spend large stretches of the day out of sight and out of earshot of their nearest relative. Permanent, dense, cooperative group life, the kind where dozens of individuals stay bonded across years, sharing food, raising each other's children, defending each other from threats they didn't personally provoke, is rare in the mammal world, and genuinely strange when you look at the cost side of the ledger. More individuals means more competition for the same waterhole, the same shade, the same mates, faster disease spread, constant low-grade social friction that never fully resolves. Group living is expensive. Something had to be threatening enough and constant enough to make that expense worth paying every single day for the rest of a species' existence. Once you frame it that way, the real question stops being why early humans lived in groups and becomes something sharper. What was so relentlessly dangerous about being alone that it was worth all of that? Let's start with the most direct answer, because it's the one you can still watch happen today in any open grassland on the planet. An animal that grazes or forages in a group doesn't need to watch for danger every second. Somebody else is usually already watching. This is sometimes called the many eyes effect, and it shows up wherever prey animals cluster on exposed terrain, from ground squirrels to grazing antelope to foraging baboon troops. Drop a baboon troop onto open ground and you'll see most heads down, eating, while one or two heads stay up, scanning, and that job rotates through the group without anyone assigning it. Each individual spends less time on watch as the group gets bigger, and yet the group's combined odds of catching a predator's approach early actually go up because the coverage stacks. Nobody has to be a hero and nobody has to be a full-time lookout. The math just works out better when it's shared. Exactly how strongly this specific pressure shaped early hominins is hard to pin down directly, since behavior doesn't fossilize the way bone does, but the underlying ecological logic doesn't change based on species. Any slow, exposed, poorly armed animal on open ground gets the same deal from proximity to others, and it's been documented directly and repeatedly in dozens of unrelated species that share nothing except the same basic vulnerability. An early hominin almost certainly didn't reason its way into this. It felt uneasy being alone, the way most of us still do, walking down an empty street at night. And the ones who acted on that unease tended to survive long enough to pass the feeling on. Heat did the same kind of work, just on a different clock. Somewhere in the last few million years, hominins lost most of their body hair, likely as part of a system built around sweating instead of panting to cool down, which let them stay active through the hottest hours of the day while heavier-coated competitors retreated into shade. That's a real advantage at noon. At midnight, it's the opposite. Temperatures on an open savanna can swing 15 degrees Celsius or more between mid-afternoon and the middle of the night, and bare skin bleeds heat fast with nothing insulating it. A single animal lying alone on open ground loses warmth through every exposed surface all night long. Several bodies pressed together solve that arithmetic almost instantly, because each individual's exposed surface area drops the moment there's another body against it. It's the same reason a pile of puppies stays warmer than one puppy left on its own, and it costs nothing except proximity. Nobody involved needed to understand thermodynamics for this to work. The physics of heat loss from bare skin doesn't care whether the animal wearing that skin knows why huddling helps. It only cares that huddling happens. Then there's the problem that has nothing to do with predators or temperature, and everything to do with how helpless a hominin infant actually is. A newborn human brain sits at roughly a quarter of its eventual adult size, which has to close entirely outside the womb, over years, during which that infant cannot cling to anything, cannot feed itself, and cannot be safely set down and left. That's a strikingly different math than a newborn chimpanzee, which arrives with a head start closer to double that fraction and gets mobile far sooner. A mother nursing and carrying a child that dependent, for that long, cannot also forage enough calories for both of them alone in an unpredictable environment. One adult's daily food gathering capacity simply doesn't stretch that far. One influential explanation for how this gap got closed comes from work with the Hadza, a foraging community in Tanzania, where researchers noticed that women past reproductive age were often the most productive food gatherers in the entire camp. The idea, sometimes called the grandmother hypothesis, is that these older women provisioned their grandchildren directly, digging and gathering enough surplus food that mothers could wean children earlier and have the next one sooner, because they weren't carrying the full caloric burden alone. Whether that's the complete picture or one piece of a wider pattern of shared childcare across a group is still genuinely debated among researchers who work on this. What isn't debated is the underlying problem itself. A hominin infant was too helpless, for too long, for one parent to manage solo. That's a second, completely independent argument pointing at the same conclusion the predator problem already pointed at. You could not raise a human child by yourself for very long. Not out there, not with those stakes. If this video is giving you something to think about, subscribe and turn on notifications. It helps us keep making content like this. That single figure at the tree line never did get faster. Human sprint speed hasn't meaningfully changed in millions of years, and we're still slower than a house cat over short distance. What changed instead was everything around it. Food solved a third problem that predators and cold did not, and it's one that even people who accept every argument above tend to underestimate. Hunting big animals is a spectacularly unreliable way to get calories. Studies of hunter-gatherer groups, the Hadza among them, have tracked how often a hunt targeting large game actually succeeds, and the number is not encouraging. On most days, a hunter targeting anything sizable comes home with nothing. Estimates from several foraging societies put the failure rate for big game hunts somewhere above 80% on any given attempt. Read that again as a lone hominin. If your entire calorie supply for the week depends on your own hunting success, and 4 out of 5 hunts end empty-handed, you starve. Not eventually, fast. A single hunter cannot smooth that out. A group can, because a group pools outcomes. Someone's failed hunt on Tuesday gets covered by someone else's kill on Wednesday, as long as the meat gets shared rather than hoarded by whoever happened to make the kill. Researchers call this risk pooling, and it shows up constantly in the ethnographic record of foraging societies, where meat from a large kill is often distributed according to strict, almost ritualized rules that guarantee everyone in camp gets a share, regardless of who did the killing. That distribution rule isn't generosity in the modern sense of the word. It's insurance, built into the social structure, because the group that shares food survives the bad weeks that would kill an individual outright. Let's bring up the strangest part of this whole story, because it inverts something most people assume about why the human brain got so large. The intuitive guess is that bigger brains evolved for tool use, for tracking prey, for solving physical problems out in the world. There's something to that, but it isn't the strongest signal in the data. Primatologist Robin Dunbar spent years comparing brain anatomy across dozens of primate species and found something specific: the size of the neocortex, the outer layer of the brain most associated with complex thought, correlates tightly with the average size of the social group that species lives in. Not diet, not habitat, not tool use, group size. Species that live in bigger, more tangled social networks tend to have proportionally bigger neocortices, and the pattern holds across dozens of unrelated primate lineages. The proposed reason is that living in a group is not cognitively simple. You have to track who owes whom a favor, who's allied with whom, who's likely to retaliate if you take their food, who's trustworthy and who isn't, and you have to keep updating all of that constantly as relationships shift. That may be the single biggest reason our brains ended up close to 3 times the size of a chimpanzee's. We didn't get smart and then decide to live in groups. Living in groups may be what made us smart in the first place. None of this means group living was free. And it's worth being honest about the cost side before pushing the case any further, because a channel that only tells you the upside isn't telling you the whole picture. More bodies packed closer together means parasites and pathogens move faster between them, a pattern still visible today in disease outbreaks tied to population density. More bodies also means more competition for the same berries, the same shade, the same mates, and that friction doesn't disappear just because everyone benefits from sticking around. Chimpanzee troops, our closest living cousins, show real violence within groups over exactly these tensions, sometimes lethal. Early hominin groups almost certainly weren't immune to any of that. The bet that group living represented wasn't that the costs vanished. It was that the costs, real as they were, came in smaller and more survivable doses than the alternative, which was a fast death alone in the dark with nobody's eyes open but your own. Which brings the whole thing back to that single figure at the tree line. On paper, that's an animal that should have gone extinct fast, and by almost every measure of individual physical equipment, most of its competitors on the savanna were better armed for solitary survival than it was. It didn't survive by growing claws or a heavier coat, because neither of those things ever happened. What happened instead is that the thing standing at the tree line stopped being singular. The eyes multiplied, the body heat pooled, the failed hunts got covered, the impossible task of raising a helpless infant got split across more than one set of hands, and the brain, doing the hard work of holding all of those relationships together, grew to handle it. The actual weapon our ancestors carried out onto that landscape wasn't a spear point or a fire. It was each other. And unlike a spear point, that weapon could think, remember, forgive, hold a grudge, and pass on what it learned to the next one without a single word being spoken, because language hadn't arrived yet, and wouldn't for a very long time still. Every advantage predators and cold and hunger could throw at a single hominin got absorbed, one at a time, by the simple, expensive, endlessly complicated decision to not be alone. Thank you for watching. More videos are on your screen now, and if you haven't already, subscribe. We'll see you in the next one.